All right, so hopefully this is recording. I actually forgot to start the recording, so I'll go back through what we just did real quick. We said when we get to one of these two steps, either a two-step equation or a three-step equation, that is the only time we do something underneath an equation. There's no other type of equation where we do this. So for example, there's doing something underneath. Here we would do this. Here we would say subtract 18, subtract 18. If we were working with a three-step equation, I already showed you one example, subtracting the 2x. Here we would subtract 0.5w from both sides. And then here we would add 4y, add 4y. So those are the only two types of equations that you have to do that on. Any other type of equation, you basically have like terms you need to combine first, or maybe even distributive property. Is there anything I missed that I went over? I think that was the only thing I've gone over so far, right? That's why they're so important. That's how you the way you recognize them. The way you recognize them is every single two-step equation will have a term with a variable and a constant on one side, and then on the other side, just a constant. So again, term with a variable, constant, and then on the other side, a constant. It doesn't matter which side these are on, so there's my term with a variable and my constant on the right side this time, but then on the other side, still just a constant. That's the way you recognize two-step, the way you recognize three-step. For a three-step, both sides have a term with a variable and a constant. So just like that, term with a variable, constant. Term with a variable, constant, term with a variable, constant on both sides. All right, so now you're all caught up, those of you watching the video. All right, so let's go back to the bell work and we'll finish that out real quick. So that's the difference between two and three steps. More importantly, it's not so much a difference between them, it's how you recognize when you're at one of those, because that's when you can start doing something underneath. By the way, so I won't get on anybody about not doing stuff today, but I'm probably not going to give you a lot of help on the exit ticket if you're not taking notes and writing what I say. Because clearly it doesn't matter to you, so I'm going to be helping the people that are answering questions and trying to learn. So it's up to you guys. All right, so really quickly, let's solve out the two-step equation. So these are the main two things you need to know to probably finish the exit ticket today. I'm not going to hold your hand and sit there and do the whole thing with you. You're going to need to know how to do some stuff on your own. First part is the distributive property. So if you see parentheses, that means you need to do the distributive property. And you will have on both sides of the big equation, you'll have distributive property on the left and on the right. So you have to do it twice. The left side is going to be pretty easy. We're going to do an example in a minute. So if that's my problem, so I'm doing this problem up here right now, just doing it down low. I see parentheses. That means I need to do the distributive property. That 4 next to the parentheses means I'm doing multiplication, because there's no math symbol in between that 4 and those parentheses. So it means I need to multiply that 4 times whatever is in the parentheses. I'm sort of not creating, but what's Mr. Gill's most important rule? Well, no, I'm asking you, what was your question?
I still need to open notes.
Yeah, you can. I'm actually even going to leave the one that I do up on the board, but if you have your own notes, that'd be even more helpful if you've actually written in some explanations.
Right.
I'm going to add another rule that is probably equally as important. Only reason I didn't have it as a rule is I was hoping we already knew this, but we don't, based on looking at exit tickets lately. We don't know this. I mean, I said it before, but I'm really going to make sure you need to write this down if you don't already know this today. So again, if you don't have this written down and you make this mistake, I will move on. Clearly, you don't care because you're not paying attention to what I'm saying, you're not taking any notes. You can never, ever combine a term with a variable and just a number. It's impossible. What is a variable? It's an unknown number. How can I combine something I don't know with something I do know and say that get an answer there? I'll give you a simple answer or simple version of that. if I have x plus 1, how can I say that's 2x? Or just 2? Or I don't know what x is. If x is 1,000,000, that's going to be a different answer than if x is 2. I can't combine those. I just leave it as x. That's all I do, x plus 1. That's why we need the distributive property. If we could combine these somehow, well, we would just combine them and then multiply them times -4. We would need to do this whole distributive property thing I'm about to do. I always hit those. They'll come back. I always hit those. All right, so no, I hit the chords and they disconnect for a second. So distributive property says I know I can't combine those, but what I can do is I can take this -4 and I can multiply it times both of the terms that are in them. And I'm going to show you how I teach this. If you do it a different way, as long as you're coming up with the correct answer, that's fine. But again, if you're not doing it my way, if you haven't listened to what I've said and you're trying something else, I'll try to help you, but if I can't figure it out, I'm going to move on. I can't sit there and fix everything that you're doing when I'm giving a whole lesson on how to do it. All right, so this means I'm taking -4, and again, the math is going to be multiplication, times 2u. -4 times -3. So here's the way I told you to do this. Don't put any addition or subtraction in when you're setting it up. You'll do that when you do the actual math. So this is a -4, so I'm using just negative sign. So that's a -4 times positive. There's nothing in front of that 2. You don't count this with the 2. Right now we're just looking at that term. That's a positive 2u. All right, fair enough. Now don't forget to multiply it times the second term. So I don't write plus or subtract right now because I'm just kind of setting the math up. So I just say that's still a -4 times negative, because now I use what's ever in front of the term. So negative subtraction is really just a negative sign. -3. Now on the right, you could go ahead and write equals 13. I'm not even write that yet. Because right now I'm just kind of setting up what math I need to do. Luckily, I don't actually use that for anything. So now, right on the board. Now I do the math. And when I do the math, that's when I'll put in subtraction and addition. So if I come out with a negative number, I'll make it subtract whatever. If I come out with a positive number, I'll make it plus whatever. Now the first term, what are the rules? What's a negative times a positive? You don't know these rules, you need to write them down on your paper. Negative times a positive is a negative. So negative times a positive is -8u. You can write with anything as long as the marker is missing. It doesn't matter what you touch it with. It'll write. I could use sometimes I do use a ruler. You can actually use your finger in 2 different ways. Right now it thinks I have a marker. If I put a marker there, I could use my finger, and then when I pick up a marker, it'll do something different. Anyway, I don't know what I'm talking about. So here's the part where the addition or subtraction comes in. What's it? So a negative times a positive, by the way, is a negative. Doesn't matter which one's negative. It could be positive times a negative. That's still negative. What is a negative times a negative?
Positive.
That's when you get a positive. So instead of writing a little positive 12, I'm going to say big positive and then 12 because I'm making it plus 12. That's when I'm writing in my addition and subtraction when I do the actual math. Now I'm going to bring down the equals 13 because I haven't done anything on the right side. Now you have a 2-step equation. I'm just going to solve this quickly. If you want to try to do it on your own from here, probably not bad to practice it. You can then look up and see if you got the right answer. First step, I need to take the constant on the side where the variable is and get rid of it. So I get rid of it by doing the opposite math. That's opposite. Well, if I do it on one side, I got to do it on the other side. Subtract 12 and subtract 12. That all goes away. It's the whole reason I did it. And that brings down the 8u, because I didn't do anything with that, so I got to bring it down. Don't forget the negative. Don't forget the variable. I get 1 over there. 13 subtract 12 is just 1. Now, again, second time. These are your steps at the top of your pink sheet, by the way. The first time, it says the first time you do the opposite math, it'll be addition or subtraction. The second time you do opposite math, it'll be multiplication or division. Well, in this case, the opposite of negative 8 times u, because that's what that is, the opposite of multiplication would be dividing by negative 8. Don't forget the negative sign if you have one. That's my answer. I don't care where you put the negative. You can put it on 1, you can put it on the 8, you can put it next to the line in between. You'll see it all different ways sometimes, as long as there's only one of them.
Oh, never.
We didn't do anything with the 8. That's been there the whole time. Oh, I divide. If you're talking about the last step, I divided by negative 8 here. So therefore, I have to divide by negative 8 over here. Make sense? You good?
I'm just confused. How'd you get negative 8 times 4?
Yeah, that's the distributive property.
Because I was confused.
Negative
with the plus
4
sign.
times 2u.
So I was confused with the plus sign. That's positive.
Yeah, it's positive. It's negative 4 times positive 2u. Yeah, but the math was multiplication, not addition. Yeah. I'm glad you asked those questions. I'm sure you're not the only one. All right, so here's where we're at. You think you're really good at equations already, you can get started. Start working on that worksheet. So you should all have that worksheet out because you're practicing for the exit ticket for the next 20 or so minutes. I'm going to do another problem. Now, I will say, for those of you that think you're good at it, this next problem is pretty much what you're going to see on the exit ticket. The stuff's in the same order. The negatives are in the same place as the negatives. The positives are in the same place as the positives. So, you may want to watch. You'll still have some time to practice afterwards, but if you really just want to practice on your own, you can do it. Those of you that are not ready yet, you're going to want to follow along. I'm even going to go over some of the mistakes I've seen throughout the day and just in prior years of teaching it. I've already briefly mentioned the first mistake, forgetting to multiply. So everybody tends to remember to multiply times the first term, but a lot of times people forget to multiply times that second term. So there's the first mistake. Should be pretty easy to correct. So again, I'm going to multiply this term times that, and that term's also times that. Always, I'm multiplying. Whenever I'm drawing these lines, I'm multiplying times those terms. Again, we talked about this one last class, that when you have a negative involved or multiple negatives, that can also get a little confusing. That's just the math part that gets confusing. That's not really the step. It's just you got to get your math right. Well, I gave you one side on the exit ticket. There's no negative. So that side shouldn't be an issue. Everybody should get that side right. They're just all going to be positive answers. You just got to make sure you remember to multiply times the second term. So one side shouldn't be bad. Second side, there's negatives, like this one. So I'll go through how to do that. Then the last thing, multiplying times a term not in the parentheses. It really wouldn't happen on this side. It's a mistake people make when they see a side like that. Sometimes people get so excited about multiplying this -3 or whatever the number is, they multiply it times that 9. That 9 is not part of the parentheses. It's a separate term being added on at the end. So we don't multiply the -3 times that 9. Those are really the only 3 mistakes, other than just making a math error, maybe. But I'll correct the math. I'll correct your math on the exit ticket. If you truly just multiply 2 things wrong, and you have the right sign, like you have it, the positive or negative correct, I'll just tell you got the wrong math there. Now, if your positive and negative is wrong, what I'll do is I'll say, you got something wrong with your positives and your negatives on the right distributive property. And you'll have to look at it and figure out. And then I'll walk away and I'll come back and I'll see if you got it corrected. And if you don't, then maybe I'll give you a little more help. So assuming that you're practicing right now. Question?
Is it going to be the positive one that's going to multiply?
I'm going to go through and do it right now. So, first step. I don't need that negative 11 for anything. I can write it down though still, because I'm kind of creating the next line. I'm really just setting it up though, so you almost don't even have to write this. You could just do this and just do that, and then make sure you bring down the negative 11 later. I'm going to go ahead and do it. Again, I don't write addition or subtraction because I'm just kind of setting up the distributive property. I don't write any addition or subtraction until I do the math. So this is a positive 5, whatever's in front of the term. So I would just write positive 5 times, that's a positive 2n. Now, again, don't forget the second term, most common mistake. Oh, there is one other common mistake too, I forgot to mention. So again, I don't write plus or subtract. Well, there wouldn't be subtraction anyway because there's no negatives. So I'll write plus 5, and then I would say times positive 6. Again, well, now I'm to the equal sign, so there wouldn't have been addition or subtraction anyway. So now I just repeat that same thing. Be careful of your positive and negative signs. This is a negative 3. So you need to make sure you write negative 3 times positive 4n. Again, I don't write addition or subtraction yet. I'll do that when I actually do the math. Negative 3 times negative, that subtraction sign is a negative sign with that 7. Whatever is directly in front of the number. So negative 7, and then again, I can write plus 9 if I want, or I could wait and do it later. So now I'm going to go through and do the math. This is when I'm really creating the next line of the equation. It's after I do all the multiplication. I would need to write the 11 for sure now if I didn't write it before. Positive times, oh, I didn't, ooh, I almost broke my ruler. Positive times a positive, so all of these are just going to be positive, so the left side should be pretty easy, like I said, but I do want to make that an addition sign now. So when I get a positive answer in this step, I'm going to go ahead and write it as addition. And then this would be positive times positive. So I get positive 30, which I write as plus 30. Everybody good? No? All good? Thumbs up? I'm not good. That ain't right. This is the other common mistake.
Oh, when you added the 5 plus the 2 and you put the 1.
Yeah. What happened to my n? What happened to my n? A variable cannot magically disappear, and I'm seeing that almost as commonly as I'm seeing anything else. You guys are so focused on doing the math with the numbers, you forget there's a variable there to start with. If there's an n there, there needs to be an n there, and that throws everything off. That's a tough one to fix too, because then you go ahead and you do the rest of the math, but now you're using numbers and combining numbers when you shouldn't have combined them. And it takes me a while to figure out where you went wrong, where you all of a sudden combined something that you shouldn't have. So do not let a variable magically disappear. The only time a variable disappears is if you do something to get rid of it, like you do the opposite math to get rid of it. All right, which we'll do in a little while. Now we do the same thing on the right. We just do the math. What's a negative times a positive, we said? So negative 12n, don't forget the variable. What is a negative times a negative?
Positive.
So now we're going to write that as addition. And then we just say plus 9 on the end. What kind of equation am I at? Oh, no. I knew somebody would try to say something at the top. What kind of equation? Is it?
No, it's the two-step equation.
Is it? You think that's only 2 steps? I got all that stuff left, and that's a 2-step equation? I got 3 things on both sides.
Oh.
Yeah, we're still in multi-step. We hadn't gotten anywhere near a 2-step. You are only on step 2. All we did was step 1. We just got rid of the distributive property. That's all we did. So you're at step 2. So on step 2, combine like terms where on step 2? If you did not underline that, you need to underline on the left side. We do not try to combine that and that yet. That would be doing something underneath. I said we don't do anything underneath until we have a 2-step or a 3-step equation. We're nowhere near that. If I've got 3 things on both sides, I'm nowhere near a 3-step equation. Certainly not a 2-step. So I don't look at the right side. I don't use this in and that in. Well, I can't do that. There. I just look at the left side. And I think to myself, okay, do I have 2 terms that have the same letter? Do I?
Yeah. No.
So what's the other end? What other term has N on the left side?
Oh, no.
So no, I don't have, again, just on the left, there aren't 2 terms with an N. So there's nothing I can do with that N. Do I have 2 terms that don't have a variable at all? Do I have 2 terms that don't have a variable on the left?
Yes.
Yeah, absolutely. This doesn't have a variable. That doesn't have a variable. So here's where that other mistake comes into play. This is what I saw all day long, mostly first period because I've been emphasizing it since then. Kids go, okay, I got it. Those are like terms. I need to combine those. And they like, yeah, that's right. I need to combine those. So here's how they try to combine them. They go, well, I need to combine 30 and 11, so I'm going to add 30 and negative 11. So I would do the opposite there to get rid of it there. And then I got to do the same thing over there to combine it. What's wrong with that?
There's so many things.
Actually, I was just going to say, there are so many things wrong.
Wait.
It doesn't have anything to do with their equal sign. That's the first thing wrong. The math is just wrong.
Yes.
If I just combine those, the correct answer would be 19. That's not 19. That's negative 41. So first of all, you get the wrong answer when you do it that way. But what's the other thing that's wrong with that?
Wait. Your rule?
Which is?
What are we right?
Yeah, what did I just do? Well, no, I did something. I did, not only did I not do it on the other side, I did it twice on the same side. I kind of made a double mistake. So that is not the way. Again, that's why I emphasized at the beginning of the class, when you don't do anything underneath the equation until you have either a 3-step or a 2-step, which we are not anywhere near yet. If you need to combine terms, like if you need to write it down and combine them on paper, because you can't do it in your head, which is fine, just don't try to do it in the middle of the equation. Go to the bottom of the paper or use a separate paper. What are the 2 numbers? Negative 11 and 30. Ooh. Say, okay, well, I need to take negative 11. I need to add to that 30. And just do the math down there. Which is what? What's the answer? Positive 19. If you don't know how I got that, again, quickly, you are $11 in debt. We'll say Celine owes me $11. We'll say Kayla is super nice, and Kayla says, hey, here's $30, Celine. You can pay off Mr. Gill and say what? I am filthy rich. You just keep the change, right? So Celine gives me the $11 she owes me, and she still has $19 left. That's the math examples we've been using with money. So I didn't do anything with the 10 in, so I can write that down still. Now I know what those 2 terms combined would be, positive 19. I know, because Mr. Gill just said it multiple times, I can't combine those because that's a term with a variable and a number. I can never combine those. I'm done on the left. All I can do. So now I can move to step 3, which is basically the same step, only on the right side. Combine like terms. Again, if they have the same letter, they are like terms. If they don't have any letter at all, like these, they are like terms. You can combine them. So we're combining the same things, numbers. That's a little easier probably, but if you need to do the math, do it at the bottom of the page, then come back up and write it down. Don't try to do math underneath or anything. Didn't do anything with a 12n because there's no other term. I'm not looking over there. There's no term over here on the right side. There's no term with an n. So I just write negative 12n. 21 plus 9, just 30.
Oh, wait.
Now what kind of an equation am I at? Now I'm in a 3-step. A term with a variable and a constant on one side, a term with a variable and a constant on the other. Everybody look at step 4 and try to do the next step. Because from here on out, I shouldn't have to help anybody. It's pretty straightforward from here on the sheet. So if you don't have the sheet out, you need to get it out. Jarvis, you know everything, not gonna do anything there. Jarvis. Try it. So, again, you should be able to do this. I'm going to give you another 30 seconds, and I'm just going to do it. I'm not going to walk around and help, because I want you to do practice on your own, and I'll walk around and help during that. But you should be trying it on your own right now, and then comparing what you got to what I'm about to put up with. This, finishing that problem. We're going to do the worksheet in a minute. Right now, you're just finishing this problem that we were working on. And I'm only going to do the very next step, and then you're going to compare it and keep working from there. Some of you will be already done. So on the sheet, actually, I don't have the sheet. Lazar, read it out loud for us. Just as loud as you can read it so everybody can hear it.
Get rid of terms with a variable on the right side of the equation. Add or subtract the opposite.
So it tells you everything you need to know from here. It says, get rid of the variable term on the right side. So here's the right side. That's the variable term, the one with the letter. It says to get rid of it, you're going to add or subtract. And it says the way you choose addition or subtraction is to do the opposite of what's there. Well, if that's a negative sign, this is not the opposite of that. That's the same sign. Same signs can't be the opposite. So I need to do the opposite, which would be addition. And you write the exact same variable term underneath it, just opposite signs. It tells you exactly what to do in that step. Now, you got to remember, the only thing you got to remember, whatever you do on one side, you got to come over here, do to the other side. So you do have to remember that, but that's why I've drilled into you that Mr. Gill's most important rule is whatever you do on one side, do on the other. Now I do the math. 10n plus 12n is 22n. I still have the 19. I didn't do anything with that. And then I still, that went away. The whole reason I did it was to make it go away. I still have the 30 on the other side. Oh, it is. And there you go. Somebody recognized that without me asking. Brandon just said it. Now we're at a two-step equation. Well, you should know how to do these. If you don't, you got the steps at the top of the sheet. It says, start at the constant on the same side as the variable. Which side is the variable on? Left, right? So I know I'm starting on the left. I just have to know that a constant is the one without a variable. Now that I know that, you should have written on your steps the other day, the first time you do math, the first time you do the opposite, you add or subtract. Well, if I got to add or subtract, and it's got to be the opposite, that means I got to subtract, because I have a positive 19 there, plus 19. Again, Mr. Gill's most important rule. Now I just do the math. That goes away. I haven't done anything with the 22 in, so I got to bring that down. That gives me 11 on the right. Again, on your sheet, you should have written the second time you do the opposite math, you're either going to multiply or divide. Well, the opposite would be the opposite of whatever's going on here. That's 22 times n. So the opposite of multiplying. So if I do it on one side, I got to do it on the other side, and I am done. Technically, that's actually not simplified. That would be the answer you would see on a like a multiple choice SAT, ACT, PSAT type test, or EOC next year. I'm not worried about you simple. Actually, I think hopefully now all of the answers should come out to be integers. You shouldn't even get a fraction. I had to fix an error earlier. When I fixed the error, it made the answer come out to be a fraction, but I think it's fixed now to where all of you guys should get integers. Yes, sir. All right, but again, you got to practice when you get back. Oh, wait, was somebody waiting? Yeah, Brandon was actually waiting. Sure? Okay. All right, thank you, please. All right, go ahead, start practicing. That's everything you need. I'm going to leave this up, and I'll leave it up during the quiz. I mean, you should have it written down. There. So I'll leave that up. Look it on your sheet. If you want to practice some of the simple ones on the first page, you can, but we've been doing those already. Look at number 16. That's about the closest one to the exit ticket. The only thing 16 is missing is it doesn't have anything added on to the end like I have here. Well, added or subtracted. All right, you guys need to start practicing. I'm not gonna. Huh? And I'm not gonna get on you. You got it. You got it. But again, don't expect help from me. So, you got it, and you don't need me. Well, everybody, not fair to everybody else. It was taking notes and paying attention for me to spend all my time with you. Here, I'm trying to find my glasses. Oh. Yeah, if you have questions, raise your hand. I'll help. I was going to do this whole thing where you. Oh, you're fine. Good. Negative. Negative. And I think the math is going. Negative. Same mistake in that. Oh well, that's one. But negative. You just need to watch that. You're fine. Remember, you're going to keep doing it, right? It's not like you do it for it. If I didn't say this today again, you're going to keep working on it. Like you're not just going to try to do it and then turn it in. I'm going to look at it and say, all right, you need to fix this, this, and this. And then get back to you. So you got plenty of chances today. We'll start it probably, and actually you guys have a little more time than others, but we'll start it in about 30 minutes. So you're going to get, oh wait, no, I'm sorry. No, that's not. We'll start it in about 10 minutes. So I want you to have plenty of time for me to help you. Because some of you will get it fast, and you'll be done, and then I'll move on to the other people that are still working on it. At least I hope some of you do it fast. We'll see, I guess. I know you guys will. But I'll still help for the next 10 minutes. So if you have questions, you're stuck on something, let me know. But again, you need to be trying at least. If you're not trying right now, don't expect me to do the whole test with you. I'm not going to sit there and do it for you when everybody else is trying. I'll get to you after I get to everybody else. So if you want to try right now, then I'll help you during the quiz. Number 16 is the one I said to look at.
Oh, okay.
Yeah, whenever you have a number on 3 next to parentheses, that means you're taking that on the x look up here real quick and I'll show you. I did the same thing here. I have a 5 and then 2n and 6, but I said 5 times 2n, so I multiply those two, and then also 5 times 6. So you're like, this matches up pretty close to your exit ticket you're going to take, and so does that problem that you're working on. That's why I said do that. And then over here, you do the same thing, only you have to be careful of your negative signs on the right. Because you'll notice in your problem there, you have some negative signs. So just be careful about the rules like positive and negative.
Number 16 has time, but I feel like that in the front. How do we do it that way?
Same way you do with anything else. You ignore it first of all. Did you already do the first step?
Yeah,
Did you do the distributive property?
yeah, that's what I'm doing.
Well, then do that first, because the 10 doesn't come into play until after you get rid of the parentheses anyway. Yeah. And actually, Brandon, correct.
Yeah, when it's a blackout.
Oh, they're all positive. You're going to want to try that one next, because that one, actually, just skip the other one. If you can do the other one, you can do the one you're on. And the other one you're on actually has a trick to it.
I don't like it.
Oh, yeah, let me point something out real well. I can't point it out because it's not, well, yeah, I can maybe. Yeah, here we go. All right, so everybody real quick. I didn't realize this was going to be as challenging as it was for kids. Look at, so I'm going to number 16. Actually, no, I'm not. When I multiply this times that x, right? There's no number to multiply in front of the x. And that's, I didn't realize how confusing that was going to be for kids. Hold on just a second. You can walk up, that's fine. Just I want you to watch this last step. There's two ways you can do this. If you understand, this is still just -3 times x, right? I mean, I'm still doing the same thing. I'm saying this times that and this times that. Well, -3x is just -3, or -3 times x is just -3x. If you really want to go the extra step to have it make sense, any variable has a 1 in front of it. So that's really -3 times 1x plus 2. We don't show the 1 because 1 times x is just x. We don't write the 1, but if it helps you to have a number in front of that variable, this would be -1x if you rewrote it. No, everything else has a number. But there's that number 16 that comes into play because there's, I think it's an n that doesn't have a number in front of it. You could just write it as 1n. Yes, sir.
So when you do multiplication with negatives, is it still the same answer? Like, do you, like, let's say -2 times 2, is it like?
Well, no, that's what we just said. The rule, you should have written this down, so when you come back in, you better write this on your paper. If you don't have it for the quiz, I won't tell you. A negative times a positive is a negative.
Okay, yeah, I get it.
A negative times a negative is a positive. And that's only for multiplication and division. That does not apply to addition and subtraction. There are no rules for addition and subtraction. All right. Yeah. Did you put your phone in there?
Yeah.
Although I think you'd be fine.
How did you get 1 and x?
Because there's a 1 there. You're right.
It always
Because what is 1 times x?
one x.
Well, what is 1 times
right.
x? Because that's 1 times x. What is 1 times x?
1
No, not 1.
x.
It's just x. Anything times 1 is just that same number, right? So if you take x and multiply it times 1, it's just x. So we don't really need to write a 1 in front of it. Because the answer to that is really just
So
x.
when x is by itself, it's automatic.
Any variable. Because how many x's are in that in parentheses? One of them. So you write 1x. That's all the number is. Remember we said the number is just telling you how many variables you have, really. This 4r means you have 4 r's. This -6 means you have technically 6 negative n's. This 6v means you have 6 v's that you'd be adding 6 v's together. So if you only see 1x, now in that case it's negative, it'd be -1x. Yeah, because what's 6 times 1? What's 10 times 1? So what's x times 1? No. 10 times 1 is 10. 6 times 1 is 6. X times 1 is x. Why do you keep saying 1?
X is what?
No, we don't
No.
know. X is an unknown number. We don't know what x is.
Yeah.
Oh,
We're multiplying x times a number that is 1. We don't know what x is. You can't say x is 1.
The thing is,
how
we
did
don't
you
want,
get 1 from the X?
because.
That's 1 times x. There's
Oh.
1x.
Oh.
Yeah, that, oh, trust me, that happens all year long. Like, I have kids at the end of the year still thinking x is 1 because there's a 1, because I say there's a 1 in front of it.
Yeah, I always used to
A
think
what?
that.
These are separate numbers. This isn't what x equals. It's a 1 times whatever x is, which we don't know. I'm not going to spend a lot more time on it. Just let's get you to the point. Just put an x or a 1 in front of it for now.